So we want to finish off today. We're going to give you guys a full workday tomorrow on this assignment. Again, reminding you of definition 2. So, whoop, that just does not work. If you have a function here, f of x, we find the derivative by simply creating one point. I call this x. So then what is my y value? F of x. And I decide to create a second point. I call this point here x plus h. So then this is f of x plus h. And what we do is instead of finding the slope of the tangent line, we find the slope of the what? The secant line. And the secant line simply connects those 2 points together. The slope of the secant line is an estimation for the slope of the tangent line. And so how do we find the slope? What do we do with those things? Y sub 2 minus y sub 1. F of x plus h minus f of x over h. Why just h? Because the x's cancel. And what we want to do is we want to find the slope of that thing. So we have to, what's the distance between x and x plus h? H. So we need to bring h towards 0. That is the formal definition of the derivative, f prime of x. Anytime you find a derivative, that's what you're supposed to use. And so we're going to use that second definition to be able to write the equations for the line's tangent. We're going to talk just a little bit about what those about their derivatives and our results. So this is something you've seen before. The difference is this time what we're doing is we're actually computing the derivative itself. So the limit as h approaches 0 of what? No, we haven't. Oh boy. There we go. Sorry. Okay, so find the derivative of the following function. State the domain of the function and the domain of its derivative. We'll see if you can remember anything about that. The domain of the root of 2 minus x. Do you remember that domain? Can't take the square root of a negative. Do you remember what the graph looks like? Goes back that way because the x is negative. Do you remember saying this, that 2 minus x must be greater than or equal to 0? Josie said it must be positive. And when you solve for that, you can see that when you take the derivative, take the derivative, when you solve for that, you get negative x is greater or equal to negative 2, or x is less than or equal to 2. So your domain is from negative infinity to 2. So that's the domain of the original function. Are we all on the same page there? And what you need to know is that its derivative is going to have a very similar domain. Watch how the domain of the derivative is similar to that, but slightly different. And here's what we have. F prime of x is equal to the limit as h approaches 0 of, and I use that definition. I plug in x plus h. And it gets me the square root of 2 minus the quantity x plus h. Then what? Minus square root of 2 minus x over h. Guess what would happen if I plugged in 0 right now? You would get 0 over 0. That's an indeterminate value, which we do not know. So how do I simplify this? What do? Do the Spanish, multiply by the conjugate, square root of 2 minus x plus h, plus the square root of 2 minus x, all over the same thing. This is where sometimes your algebra gets sloppy, folks, which is why you're getting a work day on it tomorrow. Make sure we keep our algebra nice and clean. I get the limit as h goes to 0. What do I get on the top? Can I distribute that negative through? Is that okay with you guys? So 2 minus x minus h. Minus 2 plus x over, let's be careful here, h times the quantity, square root of 2 minus x minus h, plus the square root of 2 minus x. What happens? Yeah, you can see that the x's are gone, the 2's are gone. What are you left with in the numerator? The negative h over h is going to make a negative 1 in the numerator. So I have the limit as h goes to 0 of negative 1 over the square root of 2 minus x minus h plus the square root of 2 minus x. Can I now plug in 0 for h? What's going to happen when you plug in 0 for h? Yeah, those two things in the bottom are the same, right? So if I add them together, what am I going to get? Negative 1 over 2 roots of 2 minus x. So what I just had you guys do is I had you look at the graphs and match them with their derivatives. What you're doing now is you're actually taking an equation and finding the actual derivative. So we could graph it. This is f prime of x. Now, I want you to look at it, and I want to try to compare those domains to some degree. Look at what you get here, okay? Would you agree that I still cannot plug in a value of 3? So the domain is very similar to negative infinity to 2, but it's not negative infinity to 2 with a bracket. It's with a parenthesis. Why? You can't have 0 in the denominator. 2 would give you 0 in the denominator. See how similar those are? Furthermore, think about it, folks. If you were to describe the slope of this, you would say the slope is always negative, right? And look at your final expression. Here you get this. The top is always negative, right? And when you take a square root, you're going to get positive. So this whole thing will always be negative. And if you were to look at this original function, you would say you can't take the derivative at this point right here because you can't take the derivative at the corner, correct? Well, look, where can't you take the derivative? At 2. See how it all matches together so beautifully? So many ways you can verify your answer. Let's look at the next one. This is getting exciting. Oh my goodness. What's the domain here? X can't be 3. X can be any number but 3, correct? So that means that when we take the derivative should not exist at 3 either, correct? Let's see if that happens. F prime of x is equal to the limit as h goes to 0 of, what do I plug in for x? X plus h over x plus h minus 3. Then what? Minus what? X over x minus 3. All over h. It is awesome. It's beautiful. Works out every time. What would happen if we plugged in 0 right now? You get 0 over 0. Limit as h goes to 0 of, what do I do? Yeah, common denominators. Oh, man. So difficult. Make an easy problem, Mr. Getz. We tried to do kill a tree. All right. If we multiply the top, what do we get here? X squared minus 3x plus xh minus 3h minus x squared minus xh plus 3x over, good, I heard quantity x minus 3 times quantity x plus h minus 3. All over h over 1. Instead of writing that, what could I just do? Drop the h in the denominator. What happens? Christmas happens, right? Like, yay, I get to cross stuff off. Best day ever. H's are gone, leaving a negative 3. Limit as h goes to 0 of negative 3 over x minus 3 times x plus h minus 3. Great. Can I now plug in the 0? Yes. And what do you get? Hey, what's the domain of that? You're telling me that x can't be 3. That matches with what we originally thought, right? Yeah. In fact, here's another thing. What can you tell me about the value of the derivative? If you square something, it will always be positive. So we have a negative on top, we have a positive on bottom. So you know that the slope is always negative. And so therefore, if you look at your original function looks like this. Well, what can you tell me about the slope of that original function? It's always negative, right? Down, 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 down. So the derivative is always negative. Matches perfect. God, you guys are smart. What'd you say? Say it. It's okay. Thank you. Last one. 2 over the root of x. Domain. We okay with that? Domain? Can't include 0 because you get 0 in the denominator, right? So the domain is from 0 to infinity. Can't be negative. So f prime of x is equal to the limit as h goes to 0 of two over minus oh man. It looked like to me it looks like the teacher gave us a square root problem first, and then the teacher gave us a rational fraction problem. Then it looks like he's kind of put the two together, hasn't he? So talk about finding common denominators and multiplying by the conjugate. That's what this involves. We should probably do one of them first. Which do you think we do first? Do you think we make? Yeah, we do. Yeah, deal with the denominator, folks. Yeah, just deal with that first. Yep. So square root of x plus h, square root of x plus h, square root of x, square root of x. Limit as h goes to 0 of 2 roots of x minus 2 roots of x plus h over square root of x times square root of x plus h. Everybody agree I'm just going to have an h in the denominator? That's not too bad, huh? A lot of square roots, huh? Because now, what do we got to do? Conjugate. Yeah, this is where the square roots start to hurt your brain a little bit. What? Yeah, so Asher sees something. This is what I would have done 100% when I was your age. I would have said, you know what? Let's just factor out the 2. Like if we could do 1 over the root of x, then if we do 1 over the root of x, just do that, and then the end multiply it by 2. He's absolutely right. I'm going to leave it up to you guys. Do you want to just leave the 2 in there, or do you want to factor it out? Okay. absolutely fine. You can just factor the constant out and deal with it later. That's exactly what I would have done. So I'm going to multiply top and bottom by what? Square root of x. Oh my gosh. I've never seen so many square roots in my life. So let's be careful with our algebra. 2 times the limit as h goes to 0 of, what do you get in the top? X minus x minus h over h times the root of x times the root of x plus h times the quantity, so in parentheses, root of x plus the root of x plus h. Ugh. Deal with it one step at a time, I guess. What happens? Thank goodness the x's are gone. Left with a -1 in the numerator. And now we can let h go to 0. So if we make h go to 0, it just disappears, right? So look at what you have. You have 2 times -1 over, what's the square root of x times the square root of x? X times, what's the square root of x plus the square root of x? 2 roots of x. What's going to happen? The 2's cancel. -1 over x roots of x. Or -1 over x to the 3 halves is my preferred way of writing it. That is the derivative. Yeah, because this is x to the 1 times x to the 1/2. Add those, you get 3 halves. Cool, huh? The 2's canceled. Because you have a 2 out here, it canceled the 1/2. Good work, everybody.